This presentation is going to be on engine temperature instruments. It's important to understand how engine temperature can affect performance, and there are many instruments within an airplane that can help us. Um, the engine temperature can indicate proper mixture settings for efficient flight or potential hazards and failures. Briefly, we're going to talk about the different types of temperature gauges available on airplanes. There are non-electric and electric thermometers which can be used. One version of the non-electric would be the bimetallic or solid thermometer. This uses different metals and coils welded together, and these metals contract and expand at different rates based on temperature change, and the thermometer will then give us a reading. The other is the vapor method, which uses the Bourdon tube, which has a bulb full of gas connected to a tube, and this gas will expand or contract based on temperature changes, and that will in turn move the temperature gauge. For electric temperature indicators, we have the variable resistance thermometer, which uses the principle that at different temperatures, metals will conduct different levels of electricity. And so it uses a small DC voltage, which is shot through a piece of metal and will give a reading based on how much electricity passes. And the other electric temperature indicator is the voltage generated indicator, which uses the principle that metals generate different amounts of electricity based on temperature, and using those readings, it will output a temperature reading. The first engine temperature instrument that I'm going to touch on is the exhaust gas temperature gauge. And this is important because it will measure the amount of heat that is produced by the chemical reaction during combustion in the engine cycle. This is a big indicator of the fuel ratio that is being used, and if it's correct, and if not, it can help determine the proper mixture reading that is needed. This is especially useful in a constant speed propeller, which don't allow for the engine roughness technique to be used, although it's recommended to be used in any plane that becomes equipped with it because it can save gallons of fuel and efficiency if you're following this instead of the engine roughness or maximum techniques. When the airplane is running at optimal gas temperature, that means that the stoichiometric combustion is taking place, which means that the maximum number of oxygen atoms in the fuel mixture are combining, which is the most efficient cruising configuration for an airplane to be in. Operating at a leaner mixture is much more dangerous than operating with a mixture too rich. And this is because a leaner mixture setting can lead to cylinder and pistons overheating, which will cause damage and possibly failure while operating. If the mixture is too rich, this could lead to foul spark plugs or cause the engine to gather more debris and deposits than usual. It will also increase the fuel consumption. It's important to know that if you are flying the airplane with a rich mixture, you might be using more fuel than you calculated in your pre-flight planning. So that's something to be aware of. An airplane could have either a single exhaust gas temperature gauge or a multi-exhaust gas temperature gauge. The single exhaust gas temperature gauge is only going to be measuring the temperature on what the manufacturer has deemed to be the hottest cylinder. The best way to know that you are flying at a safe mixture in an airplane with a single gauge is to increase the fuel ratio until the exhaust gas temperature is about 100 degrees Fahrenheit cooler than the maximum, so the pilot knows they are not running on a mixture that is too lean that would harm the airplane. With a multi-probe system, the pilot has the ability to be more accurate in their decision-making as to whether or not to enrich or lean the mixture. The benefit of the multi-probe system, while it's more expensive up front, it could lead to a longer engine life because you're able to be more aware of how you're running it, as well as lower fuel consumption because you're being more efficient. While it's important for a pilot to check these metrics and set them, anytime there's a altitude or a power change, the pilot should go back and readjust because, as mentioned, running on a lean mixture could be very harmful to the engine. So these are important numbers to be watching. The next instrument that we are going to talk about is the cylinder head temperature gauge, which monitors the heating and cooling of the engine. This will show, again, like the exhaust gas temperature gauge, the hottest cylinder head as indicated by the manufacturer. So if there's any concern for overheating, this is going to give you the first alert. And it's important to be aware that while this is showing you the hottest one, there could be a variation of 100 to 150 degrees Fahrenheit between cylinder head temperatures. So it's very important to not overheat these parts. That would cause them to become damaged or have to be replaced sooner than otherwise necessary. Reasons that the cylinder head temperature could be high is that the mixture is too lean, or a dirty fuel injector nozzle, a leak somewhere, or there's something blocking the engine from getting the cooling air that it needs. Whether that be a baffle is broken or out of place, or anything that's prohibiting the air from running over the engine. The last instrument that we are going to be talking about for this presentation is the oil temperature gauge, which is located where the oil enters the engine. The oil temperature indicator has 4 ranges of different colors and 2 red lines that indicate the maximum and minimum oil temperatures. Yellow is caution and green is the normal range where you want to be flying. If the oil does get into that yellow range, it would likely indicate that there is engine overheating, so it's important to be paying attention to your engine oil temperature. You should check the oil temperature before takeoff as you do your run-up and make sure that it's increasing, and it indicates green. If oil temperature does start to indicate yellow range in flight, the pilot should reduce power and lower the nose to increase airflow over the engine and allow that cooling air to wash over the engine until it goes back into a normal range. In the PA-144, there is an exhaust gas temperature gauge, the cylinder head temperature gauge, and the oil temperature gauge. The maximum temperature for the cylinder head temperature gauge is 500 degrees Fahrenheit, with the normal operating range between 200 and 435 degrees Fahrenheit. The maximum temperature for the oil is 245 degrees Fahrenheit, and the normal operating range for that is 75 degrees to 245 degrees Fahrenheit. Thank you for listening to my presentation today.